Hi, everybody. Welcome to this session. So this is a MySQL session, part of the MySQL learning fields addressed to existing customers. So in this session, I am going to discuss about the MySQL HeatWave service, specifically how to enable HeatWave for your existing MySQL workload. So I am Andreea Ciobotaru. I am a MySQL solution engineer here at Oracle. So if you do have any questions, yeah, please feel free to ask. Of course, we will be recording this session. So at the end of the session, we will have a Q&A session to answer all the questions that you have. Of course, if you have any questions later on, if you are watching the recorded version later on, please feel free to contact us. We are here to help you with any questions you might have regarding HeatWave, how to enable your environment, and so on. So without any further ado, let's get going. So first of all, what is the MySQL HeatWave database service? Why would you want to enable it? Well, the HeatWave service is actually an addition on top of the MySQL HeatWave database service. So I believe if you are here, if you are already an existing customer, so you are already using MySQL database service. So this is the MySQL database service, the fully managed service that we have on top of the Oracle Cloud infrastructure. As you know, we run underneath the MySQL 8 version, so fully compatible with on-premise installation as well. Up to date, of course, latest security fixes, also support replication and so on. Now, optionally, for the MySQL HeatWave database service, you can also enable the HeatWave engine in order to execute your OLTP, your OLAP, and machine learning in the same database. So historically, MySQL has been very good with OLTP, with online transaction processing, but not very good at OLAP for data warehousing, analytics, and so on. Quietly because it wasn't designed with that in mind. Of course, you can always tune your database services as your data is growing, indexing, and so on, more memory. However, what user would typically do is to execute analytics outside of the MySQL database and execute ETL between the OLTP application, the OLTP database, the MySQL database, and the other OLAP database. And as you know, ETL is something time consuming, it can be very cumbersome. So in the end, you end up with two databases to manage. You might be executing your reporting, your analytics on stale data that has not been recently updated, changes, the change propagation, I mean, between the databases does not happen in real time and so on. So it is in this context that we have introduced the HeatWave analytics engine. So it is a query accelerator designed to enable you to execute your OLAP, OLTP, and so on in the same database, no ETL required, automatic propagation of changes. So when you look at the picture here at the bottom of the page, you can see that you have the OLTP, OLAP application addressing a single MySQL database service. So the MDS leading node instance. And then in the back, you've got the HeatWave analytics engine, which is directly connected to the MySQL leading node, so to the OLTP front engine. So this is something that enables analytics in the cloud for MySQL on-premise as well. So, you know, for instance, we will discuss later on how you can. I will show you how you can replicate to an MDS instance in the cloud from your on-premise installation, and then add the HeatWave extension to that MDS node, and yeah, benefit from the extreme performance that that HeatWave brings. All right. So here you have a more in-depth look at the architecture. So you have this HeatWave, this parallel high-performance in-memory query accelerator that, it really accelerates the MySQL performance by orders of magnitude. As you can see, we have a lot of benchmarks on our website. So for design for this analytic workloads, mixed workload, and also for machine learning. So as you can see, a HeatWave cluster consists of the MySQL DB system and the HeatWave nodes. The MySQL DB system includes this HeatWave plugin that is responsible for cluster management, for query scheduling, returning the query results to the MySQL DB system, and so on. Importantly, as I said, is that the HeatWave node, they store the data in memory and they process the analytics query and the machine learning query. So basically each HeatWave node consists of an instance of the HeatWave query processing engine. So when you enable HeatWave, which I will show you later on in this session, the analytics query that meets certain prerequisites are automatically offloaded from the MySQL DB system to the HeatWave cluster for this accelerated processing, enabling you, as I was saying, to do LTP, OLAP, mixed workloads in the same MySQL database, no ETL required. All right. Yeah, another thing to keep in mind is also that the data that is loaded into the HeatWave engine is automatically persisted to the OCI, to the object storage, for this fast recovery in case of any failure in the HeatWave cluster. All right, so yeah, here you have an architecture of the actual resources. First of all, as you can see, you have your tenancy. In your tenancy, in the tenancy, you have created a VCN. You are already using that. And then you have your resources in this VCN. So you have two subnets, one in green, you have the public subnet, which can be accessed directly from the internet. And then in red, you have your private subnet, which is not accessible directly from the internet. So in the public subnet, we typically have a compute instance that we are going to use to access our MySQL DB system, okay? And then you have your MySQL instances in the private subnet for which we are going to enable the query accelerator. All right. So let's see. So the first thing you are going to do is to go into the database section here and into DB system in order to create our MySQL database service in OCI. So we go to databases, then DB systems, and here you have the option of creating your DB system. You already see that I have one here created, but for the purpose of this, I have here the create DB system screen. So what you have to do is, of course, you select the compartment, you give it a name, then you have to specify here the HeatWave option. So as you can see, you have standalone, high availability, and HeatWave. You enter the admin, so the admin credential, configure the network. So for the networking, we basically select the VCN where we want to place this, also the availability domain, and later on we configure the hardware. You can basically change the shape for HeatWave here. We have this, I will go with the default shape for HeatWave here. You can also configure the backup, and also in the networking section here, you have here a closer look. You can also give it a host name. Now, in the lower part of the screen, you can see the option of importing data. You have the option of, so you can either use this option here, or you can import your data in the MySQL instance later on after you have created. Okay, so the import can be done using also the MySQL shell directly into the OCI object storage, and from them into the MySQL instances. Actually, we do have a dedicated session on that that you can also watch how to bring your data to MDS. All right, so now you can see that the instance is in a creating mode in orange, and then in a few minutes we already have it up and running. All right, now we have to create, you've probably done that if you're already using MySQL database service, but so just to have all the steps in this section. So you have to create the jump host to connect to your MySQL service. I will briefly go to this. You're familiar with this. This is just something that you do in the compute instance. You just select the placement, the image, you upload the SSH keys, and then just hit create. You have your machine created in a few minutes. Okay. All right, so now in order to connect, first we connect to the compute instance that we've just created. You enter the OPC name as we do with the with the compute instance, the OPC name and the public IP of the machine, and from there you can connect to the MySQL instance using the MySQL shell that you would regularly do for a MySQL database service. As you might already know, you have the endpoint, the IP address of the MySQL HeatWave in the details page in the endpoint section. So the same as with a regular MDS that you have a provision, and you can use the MySQL shell again as you would do with a normal MySQL instance. You can use the shell with the username that you specified when you created the instance, -p-h, the IP address of the system, of the MySQL instance. All right, so now you have your compute and you have your MySQL instance. What we have to do next is to add a HeatWave cluster to our DB system. So as I was saying, you have the HeatWave cluster. Sorry about that. You have the HeatWave cluster, which consists of the DB system node, all right? And then you have 2 or more HeatWave nodes. And as you can see, you have this plugin in the MySQL DB system node. You have this plugin that is responsible for all the cluster management and so on. Okay. So now, how do we add the HeatWave cluster to our MySQL instance? Well, that is very easy to do. So in the MySQL instance page, basically you have the more actions button where you can select to add a HeatWave cluster. So here, you in the add HeatWave cluster section, you can select the shape of the HeatWave nodes. So you have this option with 16 CPUs, all CPUs, and 512 gigabytes of memory. And you also have the estimate node count, sorry. So once you have hit the estimate node count, what you can basically you can generate the estimate. Okay, so what happens in the back is that it will trigger what we have is an advisor. So it will trigger this auto provision advisor to sample the data that is stored in InnoDB, and based on this machine learning algorithm, it will predict the number of nodes that is needed. So once you have the estimations calculated, so it will show you the list of database schemas that you have in your MySQL node. And of course, if you expand, you can see the schema, select different table, and so on. So for this example, I have just the airport DB schema. What I can do is to apply the node count estimate that I have, that has been given to me, it has been estimated. All right, so now what I have to do is just to hit the add HeatWave cluster, to add the HeatWave cluster. Now the creation, the HeatWave creation will take about, let's say, 10 minutes. So, and then you can see, once you have this up and running, you can see here some information. You can see the number of nodes, the cluster size, the shape, the state, and so on. I have here 2 nodes active in my cluster. All right, so now you have your MySQL DB system with HeatWave enabled. What we must do now is to load the data into the memory of the HeatWave cluster. So again, you connect to the compute. From there, you can use the shell as we did before. Now what you can do is change the MySQL shell execution mode to SQL, okay, here. And then you just load this, you just load this, what we call the auto parallel load. So you have this sys HeatWave underscore load. So the auto parallel load is something that basically facilitates the process of loading the data into the HeatWave cluster by it's basically automating many of the steps that are involved. For instance, it verifies if there is sufficient memory available there for the data. It also has this optimized load parallelism, which is again based on machine learning models, and of course is responsible of loading your data into the HeatWave. So this auto parallel load, you can run it, as you can see, from the MySQL instance, and you see it is implemented as a stored procedure, HeatWave underscore load, which resides in the MySQL sys schema. Okay, so just calling this, running this auto parallel load involves issuing this call statement for the stored procedure, which basically takes the schema and options as argument. As you can see here, I have the airport DB schema. Okay, and after you do that, you can see the completed cluster screen in my example here. So my tables which have been loaded. Now, what you can do after you have loaded the data is that you can verify that the tables are loaded into the cluster. You see here, I connect to my system, switch to SQL, and then I interrogate the performance schema. So the tables that have been loaded, they have this avail underscore load status, okay? So you can see here my tables are now loaded. Okay, now let me bring the whole slide here. Okay. All right, so what I wanted to emphasize here is so please keep in mind that we do not only load the data into the memory of the HeatWave nodes, but we also transform it. So what happens is that data is no longer stored in rows, it is stored in a columnar way, it is stored in memory, okay? It is vectorized, it is distributed across the node. So after a table is loaded, all the changes that you do to a table data on the MySQL DB system, they are automatically propagated to the HeatWave node. So no user action is required to keep the data synchronized. So now, when the HeatWave is enabled, you have the data in your system. You can query that data, and the queries that qualify, they will be automatically offloaded from the MySQL DB system to HeatWave for this accelerated processing. Again, no special action is required. You simply run the query from the client application or the interface that is connected to the DB system, which is associated with this HeatWave cluster. So after HeatWave will process a query, the results are sent back to the MySQL DB system and then to the client application or whatever interface issued that query. Okay. Now, what you can also do is to compare the HeatWave query execution time with a simple MySQL DB system execution time. Okay, you can disable the use secondary engine variable, and you can run the query again to see how long it takes to run this on the simple MySQL DB system. Okay, you connect again to your system as before. You change the SQL mode, use the database, and then you can turn on this use secondary engine variable to use the HeatWave. So you can see you have a set session on and off. So this is something that you can do in order to compare the execution time with or without HeatWave enabled. Another thing that I wanted to put here is also the fact that you can also continue to store the data on premise, but also leverage this analytics capability, this HeatWave analytics capability optimized for the cloud. So this is something that is enabled by the standard MySQL replication, so not using any proprietary tool and anything. So by doing so, your analytics query can be run on the cloud, okay, with this MySQL database, MySQL HeatWave in the back. And this is something that totally changes the way in which you are doing analytics, data warehousing, and so on. So the inbound replication that you see here, this just means asynchronous replication from from a MySQL source, which can be your on-premise, to a MySQL DB system in OCI. And you also have a screenshot here on how you can configure a replication channel. You basically give it the host name, port, username, password of the source database, and then the MDS instance in which you want to replicate. Okay, so you can replicate here from on-premise as well. All right. All right. So now to summarize this, yeah, we have this MySQL database service with the HeatWave option, with the HeatWave query accelerator. The whole idea is to have a single MySQL database that you can use for both your OLTP and your OLAP application. And in order to enable this, basically, you do not have to make any changes to your application. It is compatible with all the existing application and connector. And as you follow all the webinars that you do, you probably know that we already have this new MySQL. It's not that new anymore. We have it already for a while. The MySQL autopilot based on the machine learning algorithms, which automates a lot of the provisioning, data loading, and so on, and also yeah, failure handling and everything. And again, if you look at the benchmark, yeah, you can see really an extreme performance, an acceleration of orders of magnitude in the execution of your analytics query. So it is something that I would encourage you to test for your own workloads. Again, keep in mind that you can also enable the analytics for your on-premise application using replication. All right. So as always, you know that you can always follow us on social media, Facebook, LinkedIn, and so on. Again, if you do have any questions now, please feel free.